Which accent do you use?
That's
Okay,
that's
a
a
mix.
divisive question.
Okay, let me share. Where do I share? There. Too many buttons to click on. Okay. And we have Teams pop-ups coming up here. Okay, so welcome everyone to another session of the Excel Toronto Meetup group. We are in November 2025. I don't know where the time goes, so we are almost at the end of the year. We have 2 more sessions to go. We'll talk about that soon. Today we have Diarmuid Early with us. It's a great honor to have him here. I've been meaning to invite him for so long, but because we always have so many people scheduled ahead of time, it's been difficult. And he was very kind to accept a last-minute invitation once someone canceled. I just reached out, and so we are lucky that Dim was available to be with us today. I'll introduce Dim in more detail in just a bit. I'll just go and let you know of a couple of things very quickly. So be mindful that our session is being recorded. It will be posted later on our YouTube channel. Feel free to follow that channel if you want to keep on top of what's going on. I will be sending an email in a couple of days, probably around the weekend, saying, here's the recording, here are the files that Dim shared with us, and a few more items that might be of your interest. So keep an eye on your email inbox. For those of you who don't know me, my name is Celia Alves. I am an Excel MVP. I've been for 6 years now. One of my main contributions, the main contribution at this point, is actually running this meetup group that I've been running. I founded in 2019. We meet every month. These past few months, we have met. We have had 2 sessions per month. We try to cover both more advanced and also the fundamental items and topics of Excel. Feel free to join us when you think it will be a nice topic for you to increase your skills and learn new things. I also work for Sheetcast as a business analyst and a trainer, a speaker. Sheetcast happens to be our sponsor. They started being our sponsor. It completed now 1 year. Just around the time I also joined them about 1 year ago. And Sheetcast, I will tell you about it a little bit more in a few minutes. With me, I have Aurora. Would you like to introduce yourself, Aurora, just for those who don't know you?
Sure. Hello, everybody. I'm Aurora. I'm a freelance consultant based in Toronto, providing data analytics solutions using Microsoft products, and I'm a big fan of Excel. I will be posting resources in the chat and monitoring it for your questions. And now let's learn together today from our guest, Diarmuid Early.
Thank you. Also, a shout out to our volunteers, Anthony, Licinia, Phil, and Valeria. They help us with the chapters, the YouTube video chapters, and other admin tasks. So it's a community effort, all that we do here. All the work is done for free on my end, Aurora's end, the speaker's end. All the work is prepared for you guys for free with love for Excel and the passion to share our knowledge. So I do hope that you guys enjoy and take advantage of the work that is done here. Okay, so Sheetcast, I was saying, it is an add-in for Excel that allows you to create web applications using Excel and the add-in. So the way it works is the data structure and the calculations are prepared in Excel, and then the web development portion of it is done by Sheetcast. So we don't need to learn how to code for the web, but with our knowledge in Excel, we can create web applications. So solutions that we were used to create in Excel, we can now make them available on the web with a couple of advantages, extra few things that are not possible with Excel only. If you are interested in learning more about it, we are running workshops every month. Take a look at the link there on the screen and register for whenever you are available. These workshops are for free. And we will be looking at a couple of little apps today because we have a draw at the end of the session to select one person to win a ticket for the Excel events, both the conference, Active Sale, and the finals of Microsoft Excel Championship and the Collegiate Challenge also, that is happening in Las Vegas beginning of December. And those who participated submitted some apps. We will be looking at those at the end of the DIMS presentation. Other sponsors, Sovereign Excel is my consulting business, MrExcel.com. Mr. Excel is offering us 20% discount on every PDF books for the members of the Toronto Meetup group. Feel free to check in the chat as well for that coupon code. Women in Excel is a group on LinkedIn for women who love Excel. Our next session in December will be about Excel with Copilot by Puneet Gojia. Feel free to join us on November 26th. And I was mentioning the discount. We are constantly getting different perks for the members. Let me quickly share this app that you will find on your on our page on Meetup. I think Aurora is also putting the link there in the chat, but just so that this is an example of a Sheetcast app. The data is an Excel table, but we can make it look like cards, for example. And in this case, we can also see images, we can embed images, we can have links. If I click here, I will go to the page. For example, now we have 10% off for the event. We have discounts on books, training sessions. By the way, keep your eyes. We will have a Black Friday sale, big sale for London. So keep your eyes on the email that I'll be sending soon. And tools that we recommend. So there's a lot of things here to explore. And under learning resources, you will be able to find the exercise files. So if you click here, you will go to the folder on Google Drive with all the exercise files for all the sessions in the past. And in case you are curious, just a brief look of how this app looks in Excel. It looks like this. So we have a table with data, and then we create a number of pages depending on the effects and the way we want to share that information on the web. And for example, here on this spreadsheet, this is where I define that card. This is how I define that to show an item of the table. Instead of showing as a table, we can show that as cards, which makes it easier to read than just looking at a table on the web. So just a quick example in case you are curious, or in case I can make you curious about it. Okay, what else? That's pretty much it. We are, like I mentioned, we are having a ticket giveaway for the Las Vegas event. In case you did not participate and are still considering to go, you can buy the ticket with 10% off based on that code available there. And other resources will go to you at the end on the email. You will receive a copy of these slides as well. And today, like I was saying, we have our Financial Modeling World Cup 3 times champion, 4 times runner-up, Diarmuid Early, with us. I'm going to just read his bio, but I have a couple of things more to say. So Diarmuid Early is the founder of Early Days Consulting, specializing in financial modeling and automation. He previously worked at Deutsche Bank and the Boston Consulting Group and earned a PhD in computer science and the CFA charter. He is 3-time financial modeling world champion, and he is also one of the most generous people I know in the Excel community. We are very lucky that our Excel community is actually composed of a bunch of generous people, but Dim is definitely one of them right there in the front line. I see him constantly sharing what he knows. He's a competitor for the Excel Championship, and he has been sharing his techniques, his knowledge, his understanding of how Excel works since the beginning with everyone. It's just a beautiful thing to see. Dim, thank you so much for joining us today again. The floor is yours. The floor is yours. Let us know what else I failed to mention, and show us what you have for us today.
Yeah, that's definitely enough talk about me. Let's let's go.
Let me make you a presenter, because I changed the settings here and then I did not put you back as a presenter. So let me just do that so that you can share your screen. Feel free to leave your cameras on if you feel comfortable with that, because it just makes company to the presenter. It makes it easier to present when we see other people's faces, unless we have trouble with internet connections, but it has not happened lately. Okay, Dim, you should be able to share your screen now.
All righty. Hello, everyone. Let me just move your smiling faces out of the way here, and let's get going. Oh no. Ugh. Now it's presenting on the other screen. That's not what I wanted to happen.
You can stop sharing and share again, maybe.
Wait. Off to a terrible start. There's got to be some. Hang on.
Maybe stop sharing and then share again.
Yeah, but this is. I guess I can swap.
Or
no,
just go to slideshow.
I need to present off this. You know, I'm just going to kill the. Just going to kill the external monitor. That's that's the easiest way.
In the slideshow, you can disconnect that next slide thing. That's another option. Okay.
All right. Well, this is probably not the perfect way, but that shows you how often I use PowerPoint.
It works.
Anyway.
That's fine.
All right. So, I mean, first of all, just hello. Great to see some familiar faces. I got to give a shout out to Kevin, because Kevin, I remember you one of the main commenters on my blog, which I haven't had a blog in like 10 years or something. So it's a blast from the past to see you here.
That's awesome.
But hello and welcome to everyone. All right, so this session is going to be about writing custom functions in Excel, specifically in grid using the Lambda function, as opposed to, you know, custom VBA functions or custom Power Query functions or anything like that. I think it's a pity for the world, but I think lambdas are still not sufficiently widely known that I'm going to spend a good portion of the time just on kind of introductory, what is a lambda, how do you write your first lambda, but then I'll also I hope to spend at least half of the time on, you know, tips and tricks and best practices and advice for kind of getting more out of them once you're up and running. So, having said that, let's start with the basics. What is a custom function? Simply put, a function is anything that turns input into an output. So, you know, actually, I think I've got my slideshow in kind of the wrong order, but I'll come back to that. Yeah, so like simple examples of like native Excel functions: sum function, inputs one or more numbers or ranges, output sum of all the numbers. The PMT function, if you use it, the inputs is like basically calculating a mortgage payment. The inputs are the rate, the number of periods, and the present value, or, you know, the amount you're borrowing if you're taking out a mortgage, and the output is the equal mortgage payment for each period. So a custom function is just the same thing. It just takes, you know, a different set of inputs and produces a different output, but a very similar idea. And custom functions are implemented in Excel through the Lambda function. I can't mention Lambda without just, you know, addressing the fear, which is, you know, that Excel goes from simple to advanced to crazy to Lambda. And, you know, there's like thunks and recursion and currying and mad stuff over here in the land of lambdas, which is partially true, but I like to present this alternative view, which is, there's two relatively independent axes, which is, you can have lambdas that are simple, you can have lambdas that are complicated, you can have, non-lambda formulas that are simple, you can have non-lambda formulas that are complicated. There's sort of an extra box up here, which is there is a degree of crazy that you can only reach by going to lambdas, but you don't have to go crazy or, do advanced recursion or anything like that to get value out of lambdas. And actually, sometimes a really simple one for something that you have to do over and over again can be the best. So I'm just going to pause the PowerPoint here and flip over to Excel and just show you. I have like a collection of a half dozen or so, mostly not mine, of like other people's lambdas. They're just like a very wide set of different like lambdas to do totally different things, just to give you a sense of the breadth of what's possible with lambdas. So start off with a couple that feel very like very like they could be native functions. So there's super XLOOKUP by Mark Proctor. So the inspiration for this is basically that XLOOKUP can handle stretching in one direction or the other direction, but not both. So what do I mean by that? So let's say I'm interested in west and south. So I can XLOOKUP west on the directions and return all 4 quarters, no problem. Or I can XLOOKUP west and south on this, returning Q1, no problem. But if I XLOOKUP west and south on these, returning from over here, then it only gives me the first column, even though I'm asking it to return 4 columns. And if you get into the weeds, it's because of how Excel thinks about arrays of arrays under the hood and blah, blah, blah. But bottom line is it doesn't work. So one way that you can get around that is you can say choose rows of this. And to figure out the row numbers, you can X match this against this. And that's a big help. But it doesn't work well with errors. So let's say if I don't know, I also wanted to look up left, and there is no left in the data, then it doesn't just error out that one, it errors out the whole thing. And so this is a little bit brittle, and you need to kind of work around it a little bit. And so we could talk all day about kind of ways to handle it and what goes on under the hood and so on, but the bottom line is Mark has written a nifty little function which he calls super XLOOKUP because catchy, that does exactly what you might expect XLOOKUP to do in the first place, which is if you look up these different things in this column returning from these 4 columns, it'll give you all of them. And if I put in left here, it'll zero out that row, but it won't break the whole thing. So one of the natural use cases for custom functions is every time you think to yourself, I wish there was a function for this, but there isn't, or probably more often, I wish this native function worked a little bit differently, had a bit of a, had a different default, was case sensitive by default or wasn't case sensitive by default, or, allowed for this edge case, or, let me put in an extra option or whatever. Then you can write your own custom function that is, based on that, but works a little bit differently. Here's another one. Again, this one is by Alan Murray, although lots of other people came up with the same basic idea, which is text between. So you've got a native text before, a native text after. Often what you're interested in is the text between 2 delimiters. So in this case, between an opening and a closing square bracket, which, for example, has an application if you ever I guess I'm not going to show you my whole file name, but anyway, if you ever use the cell file name to get the name of the file you're in, it returns it in this kind of a format with the folder path and then the square bracket for the file name. So if you want to extract the file name, text between, handy little thing. And again, these are good examples of functions that are pretty easy to do with native functions. Like the way that you get it to work under the hood is a combination of native functions, but if every time you want to look up something like this, you have to remember 4 different functions to kind of staple together, then there's a benefit in just, putting a simple wrapper on it. I saw Bill Jelen is here. I always, whenever I think about the benefit of a wrapper to help you remember a complex thing. I remember that Bill did a video, I think it was on like reversing a string back in the days before dynamic arrays, but it, you know, he had this sort of recipe for doing it that was, I don't know, 5 or 6 steps. He hired some guy to sing a tune about, you know, the left, right, mid, this, that you had to do for it, which was, I mean,
that was Tommy Two-Tone. 8675309. That was the guy. I hired Tommy Two-Tone. Great memory.
Yep. This, I mean, this is the thing, is like, whenever you find yourself thinking, I need to hire someone to sing a song so that I can remember this recipe, that should be your mental trigger to say, now's the time to write a custom function. That video was legendary, Bill. All right, so this is another one. This one's by Owen Price. Again, a pretty standard thing. If you have something like, I don't know, I've got 4 different regions selling 3 different products, and I want to list every combination of region and product. So this is just called list all pairs. So you give it 2 arrays. So, you know, in this case, it's 7 colors and 12 months, and it gives you, you know, here's every color. Sorry, here's red for every month, here's orange for every month, and so on down. It just gives you all pairs of those 2 as one array. Again, nothing that's that hard to do, but just saves you a bunch of time. I remember, you know, in the kind of pre-dynamic array days that you'd kind of go grab this and you'd say, okay, what's 7 times 12 is 84. So you'd copy that down 84 times and then sort it, and then you'd, you know, come and grab this one and copy that down to the 84 rows as well. But anyway, simpler times these days. Now you just grab Owen's list all pairs function. This one, Eric is also here, but Eric has written all kinds of cool functions, but this one is just like such an oddly creative one. It's so like you've probably seen that, you know, with VBA you can kind of go from a background color to RGB or RGB to fill in a color, but this is naming the color. So you give 3 RGB codes, and it tells you, well, this looks like antique white, this looks like light green, this looks like orchid, and it's just based on a table of 145 colors, and it just, you know, in the 3D space of red, green, and blue, it just finds the closest match and names it according to that. And I'll be honest, sometimes it does seem to miss oddly, but and you know, you could make that better by having a bigger table of colors, but it's pretty cool. And again, just like, you know, very unlike the other things, but just I always include it in here as a reminder that, you know, nobody says that these have to be like practical or functional or finance related or anything like that. It's just anything that you want to do that you can find useful. This is a great example. Here's one that is a little bit more financial model-y. I use this quite a bit when I'm building financial models. It's just a timeline, and you give it. We'll talk a little bit later when we talk about best practices about like flexibility. So you can give this like a starting date, like 2025, I don't know, 4/1, and it'll give you, you know, 10 years from there, or you can just give it a year and it'll start from the 1st of January. Those, you know, little quality of life things to make it easier to get going help a lot. But so then once you have that, it'll give you your kind of period counter, your start date, your end date, your year, month, quarter name, and so on. And then I think, yeah, this one has, you can make it do like 3 months in a period. Obviously then it doesn't have a month number, and some of the fields stop applying, and you can turn individual fields on and off. So if you're not interested in month end, you can switch that off, and you know, lots of things you can play with. But again, there's the most basic form is just kind of easy to get going with. And I've actually got a kind of bigger version of this that also includes things like, you know, what is this quarter's percent if you allocate based on a 30/360, or if you allocate based on an actual over 365, or if you allocate in various other ways and things like that. Just kind of helpful to have them all in there without having to think about them when you get going with a model. And here's a very sort of high-powered financial one. This is by Craig Hatmaker, and this is a function that builds amortization schedules. So we've got, you know, a table here with details of 4 loans, you know, first home, second home, car, boat. We've got the principal amount, the APR, the term, and the start date. and this entire output is built from that with like 4 functions. So there's one that is just, generates all the schedules themselves. And then there's one, to generate the timeline, or you can, this is actually my timeline function, but you can kind of, plug it into, like the timeline is one of the inputs here, so you can plug it into an adjustable timeline. You've got one thing that just summarizes and one thing that generates the labels. And then if you wanted to, I don't know, buy, let's say, a very expensive ring for $500,000, it's broken right now just because I've put in some details but not others, but give it a second. And I don't know, it's going to be 10% because you're spending your money on a ring. You seem like a high risk kind of person. And you're going to pay it off over 5 years and start from the 1st of January. You need to copy the formatting down, but now, no copy paste. You've got another debt schedule right here with all your proper kind of calculations. And then if you want to, you can bring the formatting down and make it look nice. And someday, formatting will expand with dynamic arrays. So it is foretold, but not yet. Anyway, so that's all just kind of various different bits of inspiration for the kinds of things you can do. Most of them are kind of vaguely kind of work or financially, but others are not. So yeah, like I said, whenever you find yourself thinking, oh yeah, I know how to handle this situation. I do this, and then I do this, and then I do this. It might be a good candidate to wrap it in a custom function. All right, so benefits I've kind of talked about a bunch of these. So let's see, easier, faster to use. Consistency and error reduction is a big one. So, for example, if you have like a complex, I don't know, a complex tax calculation, and you need to apply it to, every, month in a monthly model, or you need to apply it to every subsidiary in a company model that has like, models of 6 subsidiaries or something. And you want to make a change in that. It's just like the logic that we've always had for, if you change the tax rate in one place, the assumption should only exist in one place, so that when you change it in that one place, it flows through the whole rest of the model. But you can apply the same thought process to model logic, which is you don't want to be able to kind of change how tax is calculated on this one tab, but not change it on all the other tabs. And if you have it all running off a single custom function, you change that custom function in one place, and it applies the logic throughout the whole model. So that's a big help. And then you can also then kind of share that logic across different files or across teams, again, just to kind of keep that consistency across an even higher level. I mentioned that already. You can change the logic from one place. And separate developer from the user. So it's like, if I will say, if you're writing lambdas, there is a certain bar to write a lambda for yourself, which is quite low. Like, if you can use it and if it'll save you a little bit of time, that's great. There is a higher bar to write a lambda for a person who's going to be sitting right next to you at the moment they use it. And there's a much higher bar to write a lambda for a person who will not be anywhere near you when they use it, and who doesn't understand lambdas, and who doesn't, and who needs a lot of help. So that's just kind of one to be careful of. But yeah, same as with anything else. Same as with a model or a VBA function or Power Query, anything. Like, the further away from you it is going to get, the more robust you need to make sure it is before you let go of it. And that firmly applies to lambdas as well. So okay, now we loop back to what is a function. Functions are an input and output. So I showed you the sum function already. The PMT function takes these 3 arguments, creates an output. The weighted average function takes a set of values and a set of weights, and outputs the weighted average of those values. And the only thing that's different about this one versus the other 2 I showed you is that this is not an Excel function. So let's go make it one. We'll do it.
Tim, can I interrupt you? I already did.
Yep.
Sorry. I forgot to ask you if you prefer the questions at the end of the session, or if we can interrupt you every now and then.
Go for it. I'll take them whenever.
Okay, so there's a question by José Pérez. Are lambdas more efficient? Can it speed up a workbook that is heavy by optimizing the calculations / computation?
I would say it's pretty much an independent thing. So Lambda is just a wrapper for calculations with native Excel functions or other lambdas, but then you're just kind of nesting the wrapper further. So any calculation that you can make efficient by putting in a lambda, you can make efficient. Well, almost any calculation you can make efficient by putting in a lambda, you can make efficient without putting it in a lambda. The slight exception is there are some but not a lot of cases where you could make something more efficient by using recursion to kind of take a certain number of steps and stop when you need to stop, which you can't
And
do
for
without
that, you need a lambda.
But yeah, but that's, consider that the kind of exception to the rule. But the rule is if you can make the calculation efficiently in a lambda, you can make the calculation efficiently without the lambda. So like you can bundle up an inefficient calculation into a lambda and it won't help you a bit. You can make the calculation more efficient without a lambda and that'll help you a lot. Or you can make the calculation more efficient and bundle it up in a lambda. But I would think of it as two independent levers, basically. The one thing is that if you have your logic in a lambda and then you want to test a few different versions, we'll talk about timing later on. You want to test a few different ways, like if I don't know, sort my data and then use a binary XLOOKUP, how much faster will that make the file? Is it worth the the additional overhead of having to make sure that it's always sorted? If you have it in a lambda, then even if the calculation happens in 100 or 1,000 different places in the file, you change it in the lambda in one place, that changes it for the whole file, and you can see what effect that has. You can roll it back if you don't like it, that kind of thing. So for testing of timing, it could help to have it in a lambda, but mostly whether you put it in a lambda or not is a separate question from whether it runs efficiently, I would say.
Thank you.
All right, so let's pop back over to Excel land. And so here's our weighted average. So we've got just records of sales. So we sold 24 units at $473 a piece. We sold 21 units at $493 a piece, 43 at $423, and so on. We've got some surprisingly wide variation in our prices here, but never mind. I did actually, after I've used this example in kind of showing introduction to Lambda for a while, and for some reason I had it set up, I think I just randomized, but I had it set up in such a way that that the biggest numbers of units sold had the highest price per unit and the smallest numbers of units sold had the lowest price per unit, which made no sense because if anything you would expect a bulk discount. So the one upgrade that I've made today for the first time is that I flipped the order so that the bigger orders have got smaller values on average. But anyway, so yeah, if you've ever worked with data like this, you'll know you can't just take the average of the unit price because there are more of this one that is below average than there are of these ones that are above average, and so you need to you can figure out the total sales like that, and then you can divide that by your total units sold, and that's your weighted average, weighted by the number of sales. And so, here it is in just kind of regular Excel, sum of these ones times those ones divided by the sum of those ones. And if we go ahead and label these, oops, where is it? There we go. Just label these as weights and values, then we can say, okay, our inputs are values and weights, and our formula is the sum of values times weights divided by the sum of weights. So we're just replacing each of these ranges with a name. And once you've done that, you've pretty much written a lambda. You just have to, wrap the word lambda around the outside. So you say lambda, you list your inputs, and then you write your calculation exactly like a normal Excel formula. Just drop the equals at the front and replace any of these that are inputs, just replace them with names. And that is a lambda. So this is a function that takes values and weights and returns the weighted average. And if you use that in cell, it looks like this. It is the existence of a closing bracket immediately followed by an opening bracket is like a lot for an experienced Excel user to wrap their heads around, because that should never happen before lambdas. That just shouldn't be a thing. But what's going on here is, you think of this just like you would say sum of blah blah blah, like everything up to and including the closing bracket here is a function. And so you know, as soon as you've finished writing that function, you open brackets and call it on something. But you can also take all of this and put it into the name manager as a defined name, which I have done, and then you can call it like this, just average.weighted this and this, exactly like it was a native function. I tend to kind of name my functions, you know, in not all uppercase, or, you know, I often put an underscore at the start or other things like that, just as a way to kind of make it clear to me or to anybody else looking at my file, if they see, you know, average.weighted, just to make it clear that that isn't a native function, so that they know, you know, that they might need to kind of look it up or whatever. But yeah, that's the thing I mostly want to emphasize here is, you know, if you can write this, then you can write this. And actually, I think the PowerPoint version kind of shows it even more clearly. So, you know, you list your inputs, write your formula to calculate the output, and then just wrap lambda around the outside. And that's the only change you need to make from here's my list of inputs and here's my thing. Commas in between, lambda around the outside, and you've written your first lambda. And, you know, it can certainly get more complex from there. Some of the examples I'll show you will. But again, just back to the point of, you know, there's a very strong fear association of, you know, lambda equals scary. And there are scary lambdas, there are extremely complicated lambdas, but just because it's a lambda doesn't mean it has to be scary, and just because it's not scary doesn't mean it can't be helpful. So that's
Dim, can you please just show on the name manager for anyone who may be watching now or later who never created a lambda on the name manager?
Yep. So if you go to formulas on the ribbon and then to name manager, this one has a bunch, but right here it's just got average weighted, and it's in here is exactly what was in the formula over here.
Yeah, thank you.
Okay, so the next thing to talk about is, like I said, simple lambdas can be very helpful, but if you want to write a lambda that is a little bit more complicated, then you're going to want to use the let function. And I realize I don't actually have, I have a slide or a page like this somewhere with an intro to the let function, which I might remember to add in here before I distribute this, but I don't have it with me. So let me just, well, let's just do a simple example. Let's say we've got revenue of 100 and cost of goods sold of 70. Then our profit is the revenue minus the cost of goods sold, and our margin is our profit divided by our revenue. So, you know, simple kind of two inputs and then a two-step calculation. So if you wanted to write that as a single cell function, I mean, you could just, you know, take it all and mash it in together. But if you want to sort of have a single cell that captures both the sort of documentation of the labels and, you know, the input values and the calculations along the way, then let is a good way to do that. So the let function says I'm going to define a series of kind of interim values, like saying let revenue be 100 and let COGS be 30. And then, as well as being values, these can be calculations. So let profit be revenue minus COGS, and you can refer to, you know, the values you've defined earlier, and then let margin be not im argument. Thank you. Margin be profit over revenue, and then once you kind of make all your interim definitions in pairs. So here's the name and here's the value, here's the name and here's the value, here's the name and here's the calculation, here's the name and here's the calculation, and then you just say what you want to return. So in this case, we want to return margin. What did I? Oh, sorry, I made that 30. Anyway, seamless. And so we get to the same kind of 30%, but we've got all the sort of logic recorded within the cell. And you don't have all these helper cells visible, but you do have it set up in such a way that if you want to say, wait, so what was profit again? You can just say, oops, obviously this is a pretty trivial example. You can do that in your head, but oh yeah, okay, profit was 30, that makes sense. Now let's go back to margin. That's 30%. Okay, cool. Wait, what was revenue again? It's 100. Okay, obviously it would help if I didn't have to keep changing the number format every time I change it, but you get the idea. That is a very simple example of a let. So the thing with Lambda is that if you want to make a bigger or more complex calculation, laying it out like this as a let, where you kind of put a sensible label on every step along the way, is a good way to go about it. Also, and relatedly, when you're writing this, like writing this stage as a let and then converting it to a lambda is actually a good way to write a more complex let. So let's look at some examples. This is writing let to make it easy to convert into a lambda. So if you write your let in the right way, it's easy to convert it to a reusable lambda. So what does that look like? It looks like first external references only in one place. So, do something like this. Here's my reference to codes, and then my first part is the text that comes before the dash. My second part is the text that comes after the dash, not this. First part is text before this range dash, text after this range dash. Because if you want this range, A5 to B10, to become an input to the lambda, then you need it to be kind of exposed as its own thing so that you can do that. So first you pull it out into its own reference here. The second thing is to start with a naked reference as a step. So, if you have like the example we're going to talk about here is, a thing with airline schedules where you start from one big long string. And so the first thing you'll do is, split this apart on a semicolon to get the list of routes. And then you'll look at, before the dash and after the dash to get the departure and arrival airports. So you could start with, let routes be text split this cell on a semicolon and then ... But it's better to start with let route list be E7 and then routes be this calculate. Actually, sorry, that is not correct because that should say route list. Wonder how long I've had that example there wrong, but never mind. And then all inputs listed first. Oh yeah, so I guess I usually put this one after the audit tab because I'll show you the example there. It does literally break all the rules. But if you have this set up, then it's super easy to like write a let that's like let input A be this, input B be this, and then a bunch of calculations, and then we get to an output and convert it into a lambda. You just say lambda. So you take the inputs that are going to become lambdas, you put those up here. You take the values and you put those down at the bottom in brackets, and then all the rest of the let stays the same in between. So probably be a little easier to understand this with an example. So let's take a look at this example. I'm going to shrink up my formula bar so I can show you this step by step. So this is based on an esports challenge. So the idea is you're given a schedule, which is this long list of routes, and then you've got some data here. So these are the codes, these are the cities. We've got a flag for is it in Canada, yes or no, just because this question was about what is the total distance of flights departing from or arriving in Canada. And then we've got a table here, which is, for this departure city and this arrival city, what's the distance between them? And so we kind of do these calculations here. So we say, text split this to give us text split this on a semicolon to give us the list of routes. Then we can take the text before the dash to find the departure city and look that up in the codes to find the actual city name. So that's departure city. And same thing for arrival city. We can take the text after the dash to find all the arrival airports and look that up in the codes to get the city. And then we can figure out, is it Canadian by looking up the departure city? in the city name to return from this yes, no, check is that a yes, and do the same thing for the arrival city, put the two of them together. And then we can do the distance by saying the sum of this distance where the departure airport is the departure city we worked out and the arrival airport is the arrival city we worked out. And then the answer is just sum of if is Canadian, then distance, otherwise 0. And there it is. It's 117,107. No questions, right? Except you probably do have questions like, wait, can I see some of those in between steps again? I'm kind of slightly blending topics now, but I'm going to allow it. So yeah, part of what I mentioned was, you know, that you want to have, you want to start with naked references if you want to set it up for conversion to a Lambda. So, so this is the wrong, you know, this shouldn't be buried in the middle here. We should start with something like root list be that cell, and then every reference to, every reference to that cell after that should be replaced with root list. Because then if we want to make root list a variable for our Lambda, it's easier to do that. So that's that. But then the sort of separate topic here on this tab is optional audit details. So one of the really cool things about let, and you can carry it over to your Lambdas as well, is the option to show a sort of a debug mode or an audit trail mode. So let's just show you that one here. Well, sorry, I'll show you in the formula first. So this is why I kind of showed you the formula all scrunched up first, because I didn't want to show you some other bits. So we do all the interim calculations that I mentioned, but then we also do this other calculation, which is called check. So we stack the names of all the interim steps along the way, and then we stack, so we, you know, take that array, and then we stack all the interim calculations themselves, and then we stack the labels above the things themselves, and that is our check. We calculate our output, and then if this debug cell is set to true, then we return the check, otherwise we return the output. So now let's change that to true, and it outputs, oops, let's just shrink this up. Shrink that up. So it outputs, okay, so this is the route, the departure city, the arrival city, is it Canadian, and the distance. And then it makes it very easy to do kind of spot checks to say something like, okay, I'm going to filter for Montreal and make sure that always says yes for Canadian, and it does. I'm going to filter on the arrival city for Toronto, make sure that always says, okay, yep, that always says yes to Canadian. I'm going to filter for Canadian and just do some spot checks. Yeah, I see Toronto, Montreal, Toronto, Montreal, Montreal, looks good. And then I'm just going to sum up the values where I filter for that, and that's 117,107. And okay, now I feel good about that being what I wanted it to, and now I can just fold all my interim calculations away again, and they're gone. Yeah, that's another of the kind of things that I love about Lambdas is the ability to kind of take things and fold them away like that. But so going back to the thing I mentioned about best practices, you know, I started off first of all with you know, with a reference in the middle of a calculation here, but also I have another cell reference right down here at the bottom, which is this kind of check for am I in debug mode. So again, if I want to ever be able to convert this into a Lambda, then I should just say debug is that, and then way down at the bottom, this should be if debug. And then once I've done that, let's say that I want this to be a Lambda that takes a root list and a yes or no for debug and does all this stuff, then exactly like I kind of illustrated on the previous one, we'll say Lambda will take these two values here. So Lambda root list and debug, and then we'll just get rid of those two from here. And then all the other calculations remain exactly the same. There's nothing at all to change. Come all the way down to the bottom, close, and then just point that at the root list and debug. And then you can take that whole Lambda, and I think I've already done it. I've got a Canada dist calc or something like that. Oh, I've got multiple different Canada dist calcs, but anyway, fine. So Canada dist calc of, wait, that does not seem to be a Lambda. Was it new Canada dist calc? I'm confused. What did I do with these? Canada, oh, okay, well that's broken, so I don't know what's going on there. Let's try new. That's broken as well. Okay, well, I guess I don't know what's been going on here, but all right, let's do it. So you can just copy Alt MN or go to the same place in the formula bar, type in your name, Canada Dist Calc, tab down to there, paste it in, hit OK, hit close, and then you can say Canada Dist Calc of, here's my root list, and I want debug mode, and it spills the whole thing out, or I don't want debug mode, and it just gives you the answer. And actually what I'd prefer is to make this optional. So if you put an argument in square brackets like that, it means it's an optional argument. You don't have to provide it. You're almost certainly you've seen this in native functions like this. It's actually denoted in exactly the same way as well. So like you can do the PMT function. You have to have a rate and a number of periods and a present value. You don't have to have a future value, and most times you won't. And you don't have to set a type because there's a default. And it's exactly the same with a custom function. So you can put that in square brackets just like that, and then copy that again, come back to my name manager, to Canada Dist Calc, put it in here, paste, close, yes, save the changes. And now, because, really all I want is, if I want to know the Canada Dist Calc for this list of roots, that's the only argument I should need to give. And then if I want it in debug mode, then I can say 1 or true or whatever, and it'll give me that. Okay. So what else did I want to say about? Oh yeah. So one of the kind of practices I'm fond of in general is different output modes. So like a debug mode or verbose mode or audit mode or something like that is one of them. Craig's function over here is a great example of another, which is a help mode. So all of Craig's 5G functions, they all have, this main one is amortize lambda. If you look, they all have only optional arguments. And the logic for that is if you call them with no arguments, you get function help. So, this is the function, it's amortize lambda, it has these arguments, this is the description, creates an amortization schedule array for one or more loans, assumes all payments are made monthly, use label, it says use these lambdas that go along with it to apply labels, to apply totals, which are these other functions that I showed you up here. This is the web page where you can find information about it. This is the version date, these are the parameters, these ones are required, this one is optional, and here's an example. So yeah, it's just, again, this is as you think about like what's for me versus what's for everyone who will ever use this later. If it's just for you, then you could probably just keep your own, wherever you store your lambdas, you could have a few usage examples or something like that. But if the lambda is going to ship with a workbook to somewhere else, then it's great to just be able to tell people, hey, any of the lambdas you want to know more about, just enter it with no arguments and it'll give you all this help stuff. Or, if you enter it, I think if I remember rightly, so like here it says there are 4 required arguments. So I think that if I enter like 1 argument, it'll still output the help. So in other words, if you don't give it all the arguments that it requires, then it will say, whoa up, you're using me wrong, which probably means you don't know enough about this function. So here's a bunch of help about this function, which is a pretty cool idea. So yeah, there's the the debug mode, the details mode, whatever. There's the help mode. The other thing, just to kind of think, it's worth spending a lot of time thinking about is the defaults. For example, if you say find A in Madrid, it says, nope, it's not in there. And the reason for that is because find is case sensitive. Now, depending on which functions you're used to using, and depending on where you use them, you might not often have to think about case sensitivity. But we're very much used in Excel to the idea that you know, uppercase A is equal to lowercase a. A lot of, you know, serious programmers would look at that and kind of scoff, because of course uppercase a and lowercase a are not equal to each other, and you know, we're just being coddled. But you have to be careful because, like for example, if you use the regex functions, they are case sensitive. So if you say regex test of this for A, that is true. But if you say regex test, does it contain an uppercase A, it's false. There's an optional argument to say make it case insensitive. And similarly, like the new text before is also, I think, am I going to get this right now? Text before that A, yeah. Text before is also case sensitive, which I have to kind of remind myself of periodically. But so if there's one of these functions that you use a lot and you constantly wish to yourself, oh my God, I wish this was not case sensitive because I never want it to be case sensitive, you can, you know, write your own version. So let me just go to a clean file and pull in my regular lambdas. So split me up. I've got one that I use all the time in esports land, which just splits a word into its individual characters. Oh, actually, sorry, that's not the one I meant to. Let's just say I've got another one that counts how many times a letter occurs in a string. So like there are two P's in here, and there are still two P's in there. Now there's no, you know, count occurrences function in Excel. So the standard way to do this is to say length of this minus the length of what you get when you substitute out whatever. Let's say we'll do space. Sorry, substitute that, replace it with nothing. So there's two spaces in there, but if I do that with a P, then it'll say 1, because substitute is another function that is case sensitive. And so, you know, if you want it to be case insensitive, you can say, you know, lower of that and lower of this. But it's the kind of thing that if most of the time you're counting, you know, you're counting in a string that's only uppercase, or you're counting the occurrences of numbers or something like that, it's very, very easy to forget that when you go and look at how many times is lowercase a in there, it's going to be case sensitive. And so having a function like this, I'm just going to edit lambda, having a function like this where you can say, you know, if it's case sensitive, then lowercase them both before you make the comparison, without having to remember that all the time, is, you know, a great case for using custom functions. But also what I was mentioning is think about the default that you want. So I can say how many, sorry, wrong one, countoc. I can say how many uppercase P's are in here, and there's 1, or how many lowercase P's are in there, and there's 1. But, you know, I'm using substitute where by default it is case sensitive, so the uppercase P doesn't get replaced. But my function by default is case insensitive, because that's usually what I want, just from experience. And so if I don't think about it, then it's case insensitive. And so taking the time to think through, like, what is, I've got another one that I use a lot, which is just for flipping a sequence. So you say flip of this, and, you know, it flips it back to front and upside down. So the 25 that was on the bottom right is now in the top left, and this, you know, this 21 to 25 that was along the bottom is now 21 to 25 in the other direction along the top. So most of the time I use this either on, you know, a column vector or on a row vector, on something that's one-dimensional. And so most of the time there is only one interpretation of flip. But when it's 2D, then, you know, potentially you could mean flip it horizontally but not vertically, or vertically but not horizontally. So the way I've written that is I have two optional arguments, which are not horizontal and not vertical. And so why do I make the argument be not horizontal as opposed to horizontal? Because I want leaving it out. I want omitting it to be the same as putting in a 0. And so, you know, if I make it a 1, then it says don't flip it horizontally, just top to bottom. And if I make the vertical a 1, then it doesn't actually do anything, and it's the most pointless function in the world, but you get the idea. But so if I had to say, you know, I want to flip it horizontally but not vertically, or I want to flip it horizontally and vertically, it just means I have to put in these arguments every time. Whereas if most of my usage is on one-dimensional things where there's only one flip to think about, then it's much faster, it's much more convenient if 99% of the times that I do flip, I don't enter these arguments at all. So thinking about, you know, what arguments can you omit, thinking about the right defaults is quite helpful. Okay, so that's a thing. One other thing is that often you'll want to sort of handle different cases as soon as your input comes in. So a few examples of this. So something that comes up very often in esports land is you've got something like, you know, you start off in cell B3 and you take 3 steps to the right and 1 step up, and where do you end up? And so the way that I usually handle this is by converting everything into these sort of RC codes, where it's, you know, the RC code is 1,000,000 times the row number plus the column number. So like B3 is 3,000,002, and a right arrow is 1, and an up arrow is -1,000,000, and a down arrow is +1,000,000, and, you know, diagonal arrows all have their own codes. And then if you want to say, you know, what happens if you start in B3 and take 3 steps to the right and 1 step up, you just add all those things together, and then, you know, I have a function to turn it back into an address, but, you know, you get to 2,000,005, which is row 2 and column 5, which is E2. But you'll notice that it's the same function that is pointing at B3 as is pointing at the arrows and returning the value. So like one of the first things I want to do is say, you know, this function can take in arrows, it can take in addresses, it can also take in like lists, so like A1, B2, C3, 2RC ref, and it'll apply to each one of those, or it can take in, I don't know, something like, let's just grab a couple of these. It can take in something like, you know, 3 diagonally up arrows and 5 diagonally up and right arrows, and it'll say, okay, well, 3 diagonally up and left is this, and 5 diagonally up and right is that. And so it basically, this is a complex function, to be clear, but one of the first things it does is say, okay, there's lots of different kinds of input I might have. I might have, you know, I might have a single address, I might have an arrow, I might have a list of addresses, I might have a mix of arrows and numbers as multiples, and actually it can handle lots of other things as well. So if you said something like, you know, 3 up and 2 right, it can also handle that if you tell it that you're talking about, or see, no, sorry, dir is up, down, left, right, that one. It can interpret those as well. So 2RC ref. Now I'm going to show you the function, and it's going to be huge and crazy and intimidating, so don't worry about the whole thing. But there's a particular part of the setup that I want to show you, and that is the very first branch in the function is an if, and it says if the count of the input is greater than 1. In other words, if I have multiple inputs, oh, sorry, I guess that's the other thing I didn't show you, which is it can also handle like an array of inputs like that. So the first thing it does is say if I have multiple inputs, like, you know, an array of inputs, then proceed down this branch and do this stuff with it. And gosh, hang on. So that's my test, that's my first branch, and then my second branch starts down here. And if it's not, then, you know, proceed down with this branch. And in the case where it is proceeding down this branch, so this is the branch where it's been called on only a single cell, that's the case where it has to allow for the possibility that that cell might contain a list of values. And so within this, it does some tests, and then it calls the function itself again. And it does that on, a split up version of the input using regex extract. And there's a bunch of other kind of cases and things here as well, but you can see basically everything in this second branch like does some processing, like splits the input up, and then calls the toRCref function again. So you give it a list like this, and it splits that into an array of separate values, and then feeds that back in. And that, when you come to this test, says, okay, well, hang on, now I've got multiple inputs, so now I'm going into this branch, and this is the branch where it actually sort of does the work. And then this other branch, it just sort of processes it into the right shape to send back in. The one word of warning with this, like it makes the function much easier to write because you don't have to write the sort of meat of the function two separate times, once for, if there's a single input and again for if there's multiple inputs. But if you edit the function in cell, as I do, when you're making changes, it's easy to forget that, you make your changes here and whatever, let's say you're calling it on something like this. You make some changes up here and you hit enter and you notice that these don't change. It is very easy to get confused because you forget, oh, hang on, there is a recursive call in here, which means that the recursive calls are going to the version that's saved to the name manager, while what's going on in this cell is the version that I'm editing now. So if you make changes, you then also, if you use this kind of recursive call for the separate branch, you then have to make your changes, make sure they're saved to the name manager, and then come back. It's also easier if you just do your editing in the advanced formula environment, because then you can just hit save. But that's just something to be aware of. The other thing to be aware of is just make sure that you don't end up in an infinite loop. So when I first wrote this function, I tested it on something like, A1, A2, and I tested it on something like A1, B2, B2. And, when it got this, it split it into an array and then handled it like this. But then the first time that I used it on a single value, it said, okay, well, this is not multiple values, so I'll treat it like a list. So then I'll split it into values. And of course, it only splits into one value, and then I'll feed it back into the function. Oh, here I have A1. That's not multiple values, so I'll send it into the second branch, split it up, and it just stuck and errored out. So that's why there is now this test up here. It has an optional argument called just one per cell, and if that is true, then it forces it into the first branch, and then all the recursive calls in the second branch make that argument make it a 1. So it's kind of saying, because all the recursive calls happen in branch number 2, and because any recursive calls force you into branch number 1, the most calls you can ever have is one recursive call, as opposed to getting stuck in a loop. So that's just something to be careful of. The other option, and I realize we're getting hairy now. I'm going to show you probably the craziest function I've ever written. And again, you don't have to worry about the whole thing. I'm just going to point out certain aspects of the structure. But so this is a sort of generalized version of index and choose rows and choose calls and XLOOKUP and a bunch of other things. It's like a data picking function that you can give all kinds of different inputs to. But the idea is, you give it an array and you give it the row slice you want and the column slice you want and where the row headers are and where the column headers are and a bunch of other lots and lots of optional arguments and lots of weird things that it can do. But if you omit the two slices, so this is kind of the equivalent of, if you call index without telling it the row number or the column number, then what it outputs is a function that is only expecting these two and is already preloaded with everything else. And so I had originally achieved that with a recursive call, and then it was getting extremely hard. I mean, this, just to give you a sense, this function is large and very complicated. So it was getting very hard to debug with that recursive call in there. And so I restructured it to say, basically at a macro level, there's kind of, first it defines this slice function, which is, you know, a sort of helper lambda. Then it defines this function, which is the function with no arguments. And then right at the end, it just says either return the function with no arguments or call the function with no arguments on the two potentially omitted arguments, depending on whether you've omitted them both or not. So that way you get the sort of only write it once benefit of the recursive call, but you don't actually have to make a recursive call because you've made, wherever it's gone. God, this thing is hard to navigate in the formula bar. Because you've made this this interim step be a function itself. Now, obviously, writing functions as interim steps in lets within lambdas is getting into dark magic, but that's an option. All right, so that's the kind of self-referencing, the recursive calls. The last thing I want to show you is.
Can I ask something before you go to the next one?
Yeah, absolutely.
There's a question from Deepak asking, how do you approach writing complicated functions? Do you plan it out on a whiteboard first? Or you just go use the advanced formula, I'm supposing, or how do you do it?
I actually mostly don't use the advanced formula environment. I mostly just write in the formula bar. Although the advanced formula environment is probably a better bet, certainly for most people. Maybe even for me, I don't know. I'm not sure about that part, but definitely for most people. I would say I only quite rarely go to the kind of lengths of writing it out longhand. For this function, I did because it's wild. But most of the time, I sort of have an idea in my mind of what I wanted to do. I would say I do. I've been doing like a live session most Fridays. I aim for 11 a.m. Eastern time, which I call the LAMBDA Lab, which is just kind of live streaming me playing around with my esports LAMBDA collection, including I wrote most of this live on the stream. It was a very long stream that day. But yeah, so if I mean, depending on how thorough an answer you want to the question, what does it look like when you're writing lambdas? There are hours of footage of me writing lambdas available that you're welcome to watch. But yeah, for this one, I wrote out in quite a bit of detail what I wanted it to do in various different situations. Most of the time, I don't do that because most of my functions are intentionally much, much simpler than this one.
Mm-hmm. Thank you. There's another question. Can one call Lambda functions from VBA code and use it from VBA or within VBA, I would think?
I don't know, honestly. I've never tried.
Okay.
I would guess so, but I don't know.
Yeah, not sure either. Never tried. If you didn't see this Lambda for a year, how long would it take you to understand it again?
Well, it depends a lot. If I just saw the Lambda, a lot longer. If I saw the Lambda with like a collection of usage examples that made it clear, like, okay, so these are the kind of inputs you can give it, the kind of behavior you're expecting. Here's an example of what it looks like if I, give an argument here versus if I don't, or here's an example of what it looks like if I provide, a single number here versus if I provide an array of header labels. If it's well documented, then I think, like, I kind of showed you what it looks like if I just scroll down through this thing. But if I'm editing this, I have a good sense of the sort of macro structure of this, in the sense that, like I said, here there's the slice lambda, and then there's the definition of that, and then there's the pick no slice args lambda and the definition of that, and then there's the kind of main kind of wrapper at the end, and then within each of these there's a let and there's a structure, and I have a sense of what goes where. So if I were ever in a situation where I expected to leave this for a year and come back to it, I would certainly write a few things down, like, here's what the macro structure looks like, here's the general kind of usage, here's some examples. Without that, how long would it take me? I mean, to understand all of it, quite a while. But again, this one is the exception. This one and like one or two others are the exception. I write very few functions that are as complex as this. But this one I just really wanted to achieve something that was very complex, so I had to do it. But like
you did yourself a good work of documenting and leaving a trail that you could follow.
Yes, exactly. But like most of my, I don't know, like I showed you that toAddress function earlier, that calculates or converts one of my row column references into a code. Like, I mean, this is still a little bit big, but I could read this and feel comfortable understanding what it's doing in a minute. Because, I mean, partly because it's written in my style, and partly because, this isn't doing anything too crazy under the hood. And that's most of my lambdas are more like that. All right, I'm going to show
just
you
one note here. So Eric OM is saying, if I understand it correctly, that VBA can call lambdas using application.evaluate, but he does not recommend it.
Ooh, okay, yeah. If that's the only way, I would also not recommend it. That's a function best avoided, I would say. All right, so the last thing briefly is just timing functions. So this is a kind of a mix of an example of a function you might want to do and how you might time two different versions of it. So here we've got a bunch of input data, which is whatever invoice and a state ID code and then a date code or something. I think that's meant to be a date code as year, month, day. And you want to split that into three columns, one of which is the invoice, one of which is the state, and one of which is the date code. And the problem is, just like what I showed you with XLOOKUP earlier, if I say, so let's just start with if I say text split of this by that, it'll split it nicely into three. But if I say text split the whole thing by that, it won't split it nicely into three columns because arrays of arrays make Excel sad. So a couple of ways you can get around that. One is this approach, which is basically you join it all into one giant string with a second delimiter, and then you call one text split, which splits on this into columns and on this into rows, and that splits the whole thing out. Or the second option is you can use a mix of text after and text before. So you can say, basically text before the first, second, and third dash. So the text before the first dash is just inv, and the text before the second dash is inv dash OK, and the text before the third dash, matching to the end, is the whole string. And then you take text after the last dash in that. And so that for the first column, that just gives you inv, and for the second one, it gives you OK, and for the third, it gives you that. So both of those methods work and get around this, but you might say to yourself, okay, well, I want to use the faster one. So this is a way to kind of time a function using the let function. So the idea is that basically let evaluates each variable in order. So you say let the start time be now, and then you do a bunch of calculations, and then you call now again and subtract off the start time, and then format that as time in seconds with 2 decimal places. There's no point in having more decimal places because that's as accurate as now goes. And you will get, obviously, hardware and variations and whatever. You can see this one is pretty consistently coming up as 0.00. This one is occasionally coming up as 0.01. They're both very fast, basically. If you need to, you can kind of repeat it many times to, so like, here, accuracy to 100th of a second isn't enough to tell us which of these is faster, but if you do it 1,000 times, for example, then it will tell you, okay, so now instead of the output just being do this, the output is like do this 1,000 times, and then tell me where you get to. So now you can see this first method calculates 1,000 times in 0.3 seconds. The second method calculates 1,000 times in 3.5 seconds. And so the first method is much faster. But on the other hand, the first method is also potentially more brittle, because if your combined string gets too big, specifically, I think the limit is that the combined string can't get over 32,768 characters or something like that. 2 to the power of, what even is that? 2 to the power of 16? No, 15. Let's see. 2 to the power of 15. Yeah. I think an output of text join can't be longer than 2 to the power of 15 characters. And so if your data gets too big, this method will not work, but this method will continue to work. And also this method, if you were only interested, let's say there were, 12 columns in this, or 18 columns, or 100 columns in this, and you were only interested in the 7th column, then you could use this with just a fixed 7 here to pull out just the 7th column. So, reasons to know both, but if you have two methods that work equally well, then timing them both before you lock in which one to put into your Lambda is a good idea. And okay, I guess I can't give a talk about Lambda without showing you my favorite toy. Probably I don't know, it might have been displaced by the crazy one I just showed you as the wildest Lambda I ever wrote, but at least the funnest idea for a Lambda that I ever wrote. It is the Lambda that writes Lambdas. So the idea is that you have, some calculations. So this one is like a cipher. So you take some input text and a shift, and you want to figure out what will happen if you shift each of these letters along by 5, wrapping the end of the alphabet back around to the start. So A goes to B, C, D, E, and so on. So you can split it into letters, and then you can figure out the codes of those, and you can figure out how far away from A are those by just subtracting off 65, which is the code of A, and then you add the shift to that, and then you that should be plus 65, not plus 64, which is why A moves along 4 steps to get to E, 5 steps to get to F. Anyway, again, I've used this example a bunch of times before. I've obviously never looked at it that closely. So anyway, yeah, then you can use mod with the shift. So mod 26 to get it, to get the ones at the end of the alphabet to wrap back around. So like 23, if you add 5, we'll go 24, 25, 26, or actually, sorry, 24, 25, 0, 1, 2. And then you can add 65 back to those to get them in the right range and take the character and combine them. The specific calculation going on here is not important, but the point is that you can then use lambdify. Lambdify wants 2 mandatory arguments. One is the list of names, like here, and the other is the list of cells containing the formulas here, and it has to be laid out in this way. It's quite rigid. And if you do that, it will return a text string, which is that all wrapped up into one big let, including the ability to return a check that rebuilds all the interim calculations, like the one that I showed you before. And then if you give it the optional third argument basically to say how many columns of these are input arguments. So here I'm saying the first 2 are inputs and the rest are calculations. Then it'll write a lambda that is lambda of input, shift, optional check, do all the calculations, call that on the input and the shift, and you get that. And then you can save that into the name manager if you want, or again, you can add a 1 and it'll spill out the interim calculations. So it's just a way to make it easier to go from, you know, a bunch of calculations in the way you would write them in the old-fashioned way into a single let statement or into a lambda.
Yeah, and I've used it, and it's very, very useful. It saves me a bunch of time because I was doing my reasoning with step by step, and then I realized, oh, I want the lambda out of this. I don't want to go now and type all these steps into a function. So very helpful.
Yep. By the way, I would be remiss if I didn't say that there is, since I wrote it, there's a much better version of Lambdify available in OA Robot, which isn't as, you know, prickly about, well, you got to lay them out exactly like this and you got to label them exactly like this. It's a lot more flexible and creative. So yeah, Lambdify I still recommend it as a kind of, you know, learning tool, like write something out, convert it to a let by hand, convert it to a lambda by hand, then use Lambdify to see that kind of speed it up a few times and then kind of get in the rhythm. But for let's say industrial strength applications, I don't use Lambdify anymore.
That's good. Okay, thank you so much, Dim. There's a question from Aurora. She's asking, how do you test your lambdas when they look to be working fine? Do you ever try AI, Copilot, ChatGPT, whatever, to ask them to explain your functions, or you just do your own testing?
I've never done that, but it's definitely not a bad idea in two ways. One is that at least Gemini, which is the one that I've kind of experimented a little bit with, kind of testing it on complex functions. I think ChatGPT as well. They're very good at understanding complex formulas. So if you say like, hey, I've written this 4-page long lambda, hopefully not, but occasionally you might be moved to, as I am, like, this is what it's supposed to do. Is it doing that? Like, are there edge cases where it might fail? I would say, I would never bet the house on what an AI returns, but I'd say there's a pretty good chance that if you ask it the question like that, it will kick the tires on it pretty well. But the second thing you can do is you can ask the AI to generate a bunch of unit tests and expected answers.
Hello? You froze. Let's hope that Dim comes back. Eric is saying Lambda Robot is the name of the command collection that Dim was using, and it's free. Yeah, and Eric has presented about OA Robot a long time ago. It's time for you to come back at some point, Eric, because I'm sure there's a lot of new things to show. Dim, there you are.
Don't know what happened there. My computer just hard crashed. So I'm on my phone now. But good thing we made it to the end of the presentation.
Yes, just very timely.
But
you were finishing explaining. Yeah.
Yes, I was just saying the other thing that you can ask it to do is to generate a bunch of unit tests, which, you know, depending on what the function is, that might be very different looking stuff. But like, yeah, just say like, give me 50 sets of inputs and what the outputs should be. Whether it gets the output correct or not, again, you know, do your own homework, certainly. But, you know, if you ask it, like, what are some edge cases that I might want to test this on, that kind of thing, it's quite good at that.
Good tips. Thank you.
Thank you.
Yeah, computer couldn't handle the lambdas anymore. James Ty says. Okay, are there any other questions for Dim before we just go to the end of our session? We have a ticket for Las Vegas, for the event in Las Vegas to draw. So if you have any other questions, now is the time. There's a great session. Thank you. Where's the best place to save your lambdas? Ted is asking.
Interesting question.
I'm I'm thinking he meant to reuse them in other workbooks, probably.
Yep. So depends on how widely you want to use them. Well, it depends on a bunch of things, but I would say that the first and simplest thing is just save them in one workbook and pin it to your Excel taskbar, so that anytime you go to open a file, if you want to import your lambdas, you can grab that file. The kind of lowest tech way to import your lambdas is just to add a blank sheet to your lambda file and then copy that sheet over, and it will bring all the named ranges, including all the lambdas, with it. If you're going to be doing this kind of thing more often, I already mentioned OA Robot. That is how I import my lambdas, because it makes it really easy. Or I know some people like write all of their lambdas into macro form, to be able to kind of just run a macro themselves. Seems more hard work, but it's an option. And then if you get into the more kind of serious end of things, then storing and versioning your lambdas in a GitHub gist is the sort of industrial strength way to go. And there you can, through either Robot or the advanced formula environment, you can kind of pull stuff from GitHub straight into Excel as well, to make sure that you're kind of staying on the latest version.
Another option is also Monkey Tools. It also allows you to save your lambdas on a library, and from any other workbook, new workbook, you can say inject and select the lambda you want to place into that workbook. So there's a number of options there. I think there are no more questions. A lot of thank yous and amazing and awesome session. Thank you everyone for joining. Okay, so if no other questions, if there are at some point, and Dim is still with us, feel free to pop them in the chat.
I'm actually going to have to run because I obviously talked for longer than I expected to, but it's date night tonight, so I got to get moving.
Sure. Thank you for joining us, Dim. And
Thank you for having me. It was fun.
Thank you. Bye-bye. Have a good night.
Bye-bye.
Okay, and just to finalize here, so we have a ticket for Las Vegas, sponsored by Sheetcast. The event is comprised of the Active Sales Conference for 3 days, plus access to the finals of the Microsoft Excel College Challenge and the Microsoft Excel World Championship, happening on the evenings of those days. And I requested, so the idea of asking you to create a Sheetcast app to participate in that contest was mine. It was not a Sheetcast requirement. I just thought it would be nice to have an opportunity to make people test the add-in that I think is very cool. And we got, so let me find here. We got 2 people submitting applications. I can share this. Yes, I can. I can share. We have Elliot Patterson. Just let me share here. Who submitted 2, let me maybe put this a little bit bigger. 2 apps which people could do to have more, to increase their odds, and James Ty, who submitted 1 app. So one of these 2 guys will be getting a ticket now. I asked them to submit a link for their app and a brief explanation of what the app could do. I know that Elliot is there. I see him. Is James Ty? Yeah, James Ty is there as well. His video is not on, but I can see him there. So I'm going to, let's see if I can just copy here. For some reason, the link, I think maybe because of the hashtag at the end, is not working there. Let me bring Let me bring a browser here. And let's see what these apps have. So when we create an app, we can share pages as public and others not as public. So through this link, it says there that the app is checked out. So this app is by Elliot, and it says that it's checked out, opening in read-only mode, meaning that Elliot either has the app open in Excel, or when he closed the Excel and it asks him, do you want to check in the app? If he answered no, then it got checked out. Meaning, at this point, if the app was meant for me, for example, to submit, to enter data, make changes or whatnot, not an error. It's just you just need to check in the app, meaning I don't need to have the Excel open anymore. So from this moment on, it will be available for people to use it. So that's fine. But we can see enough here. He says this is a map for, you can explain, Elliot, if you want to turn on your mic and explain what this little app is doing.
Sure. This one was really, I was just trying to get to grips with Sheetcast for the first time. So I followed the map tutorial, but it's a map of where people who have qualified for game day 2 or game day 3 are. So it has that, for example, where you were with Italy, there were 2. Most countries there's only 1, but where there's 2, it lists them out as well. The States had loads, as you imagine from these kinds of things. So there's a little bit of a display issue. I couldn't get my head around with the States because there were so many.
I think the UK also has a bunch of them, 6 people in the UK.
Yeah, we did really well in the UK this year. We did our first ever local chapter. First time running that. I was part of the team running that, which was great fun. Hadang was our champion, but we had lots of other very good players who got through very far as well. So nice to see a little bit of the community at home as well.
Yeah, it's great. Yeah, the idea was really just to have people try doing something with Sheetcast. Having this type of map is not something that we can do with Excel. We can do other types of maps, also very useful. This is just a fun little example. Then you also created another app, which was a form and attached table for collecting pre-written lambdas, including description and attribution, which I think it's a great idea and very timely for today's session. So again, it is checked out, and so I will not be able to interact with the form. All you have to do is to go open Excel, open the app, and then close it, and it will ask you, do you want to check in the app? And you say yes. That's one way of doing it. Another way is by going to app.sheetcast.com, log in with your password, and then find the app, and on the gear wheel, you can check in the app there. So this is a great idea. So we can, if people collaborate with you, this could be a nice way. People were just asking how can we store lambdas. So this could be another way. We can just enter the lambda name, put in the formula here, description, and a bunch of other information, the author and whatnot, save it. This will go into a table, and then we can call the function, call each one of the records and see the function details. So 2 nice ideas. Because we only have 3, I'm going to also show the other one by James Ty. And this one is also a map, I believe, if I remember correctly. Not this one. Can close this. So you see, would you like to check in the application? Yes. If someone tried to access the application I was showing you, you guys would have found the yellow banner there. So a map to visualize the average Microsoft Excel World Championship score by country. I didn't have much time, but that's fine. It's okay. We wanted to just have people to try. So another map page, and in here we can see the average classification by each one of the countries. So that's a nice one as well. I guess the two could be combined together and provide two pieces of information. Okay, so let's get the, how do you call it, the drums rolling, something like that. It's just 3. So we have the order in which the apps came, 1, 2, 3. The first 2 are by Elliot. The second is, the third one, last one is by James. I'm just going with run between. That's it. What is it doing? Jesus. It's interesting. Why is it suggesting those values? Let me skip. My Excel is going crazy. Okay. Runs between. Why is it doing this? It's just I know, probably because it's kicking in the formula help or whatever that now Microsoft installed. That's my guess. So 1 and 3, right? Okay, I'm going to press enter. 1, 2, 3. Number 3, James.
Congratulations, James.
Congratulations, James.
Thank you.
This is just the odds. It's just luck or no luck. Sorry, Elliot. Thank you for participating. It was great to have your 2 apps and to see them. And congratulations, James. And that's it. We will get in touch with you about the details. Thank you, everyone, for joining us today. And we'll see you soon. Any other? Yeah. Elliot, so sorry. I hope next time. I hope you get your flight booked quickly, James.
Yeah, it's already booked.
Oh, nice. Okay. So you just needed the to enter the event. So that's great. Okay.
Yeah.
Thank you, everyone. Have a great night and see you soon.